Welcome to AmeenAcademy.com. In mathematical economics, let us discuss about uses of derivatives and optimization of functions. What is optimization? Optimization is the process of finding the relative maximum or minimum of a function without the aid of graph. This is done with the techniques developed by calculus, differentiation. The function optimization describes a class of problems for finding the input to a given function that results in the minimum or maximum output for the function. Output from the function. The objective depends on certain characteristics of the system called variable or unknowns. Look at this graph. Suppose we draw a graph for different situation. Here, this graph, at this point, this is A, f dash of A is equal 0, f2 dash of A is equal 0. Now, other situation, graph is like this point inflection in this here, this at point A, here f dash of A is 0, first derivative is 0, second derivative also 0 at point A. Look at this situation. This point, x is A, here f dash of A, f dash at A equal lesser than 0, second derivative at A is equal 0. Then this situation, look at here. At this point, first derivative f dash of A is positive, greater than 0. Second derivative at A is equal 0. The point A is inflection point everywhere. Inflection point in every graph here. Now, we'll take one example. Here, we have to optimize the function, given algebraic function. Optimize. Example. Optimize f of x equal to x cube minus 30x squared plus 126x plus 59. This is a general polynomial. In this, first we have to find first derivative. F dash of x equal 2x cube is derivative is 6x squared. 2 into 30 is minus 60x plus 126. Here 59 will go 0 because it is constant. It's a first derivative. Now this First derivative, take x6 is a common factor, x squared minus 10x plus 21. Let it be, if this of x equals 0, then we can find factorizing. The factors are 6 into. In this, we can say it equals 0 means we can say x equal to 3 and x equal to 7. These points are critical points. In these critical points, we have to find f to days. Second derivative of this function is here 6x squared is 12x minus 60x is minus 6. Now we have to use the values f 2 days at x equal to 3 gives 12 into 3 minus 6 is minus 60. Is of course it is lesser than 0 because it's negative, and therefore you can say it is concave relative maximum. The concave, because second derivative less than 0 negative, concave relative maximum. Then use the second point x equal to 7. f2 days of 7 gives 12 into 7 minus 60, which is positive, greater than 0. So we have the situation convex, graph convex, as well relative minimum. Relative minimum. That means, for example, optimize the function given. First, we have to find first derivative, equate 0, and solve the equation. We give critical points, that is x equal to 3 and 7, we got it. And then find second derivative, put the point as x equal to 3 and 7. f2 days of 3 gives the negative number, so it is concave relative maximum. Then f days of 7, put x equal to 7 in this function. We have 2 into 7 minus 12 into 7 minus 60 is positive, greater than 0, so it is convex relative minimum. Next is marginal concepts in economics. What is marginal concepts in economics? Marginal cost in economics is defined as the change in total cost incurred from the production of an additional unit. Marginal revenue is defined as the change in total revenue brought about by the sale of an extra goods. The total cost and total revenue TC and TR are both functions of the level of output Q and marginal cost MC. Now look at here. In economics, the marginal concepts are associated with the effect of a small changes of an existing situation. The word marginal means additional or extra. These concepts are central to the economic theory of marginalism, which suggests that economic decisions are made based on incremental units at the margin. Look at here. First, let the given things like total cost is TC, total revenue is TR. Output, output Q. Output is Q. Marginal cost. Marginal cost is MC, and marginal revenue is MR. And now mathematical expression you can do in this way. First TC. TC is total cost, which is equal TC into Q. And MC, here TC of Q, MC, therefore you can say marginal cost can be differential of TC with respect to DQ. And TR, total revenue. Total revenue is the function of TR of Q. Then we can say MR. MR is marginal revenue is here. MR is the differentiation of TR over DQ. This is the use of differentiation to find the marginal concept in economics. Here we can take one example. If example, if TR equal 75 in terms of Q, 75 minus 4Q square, then MR is differentiation of this function, that is 75, that is you can write differentiation of TR by DQ, which is equal differentiation of this one, 75Q is 75 minus 2 into 4 is 8Q. Then if EC equal Q square plus 7Q plus 23, then what is MC, which is equal differential of TC over DQ, which is equal Q square differentiation is 2Q and 7Q differentiation is 7. So these are basic things to from TR to find MR. Total revenue to marginal revenue differentiation, and DC total cost if differentiate with respect to Q gives marginal cost. Next is optimizing economic functions. Economic optimization is the strategic use of scarce resources to maximize desired outcomes like profit or utility. Within certain constraints, it's vital decision-making tool for business and industries and can impact efficiency and profitability across the economy. Now, let us do an example regarding this concept. We can understand now. Maximize the profit. Maximize the profit. Maximize the profit pie. We let the profit is a function pie. Now, given R revenue equal 4000 q minus 33 q square. And total cost total cost is 2q cube minus 3q square plus 400 q plus 5000. Assume q is greater than 0. Now, here we know that profit from this, profit by equal revenue minus cost. Revenue minus cost, this together subtraction 4000 q minus 33 q square minus 2q cube minus changes plus 3q square minus 400 q 400 q then minus 5000. So which gives here 4000 q minus 400. Your revenue is 4000 q minus 33 q square. Then and cost function is 2q cube minus 3q square plus 400 q plus 5000. So R minus C equal 4000 q minus 33q square then minus 2q cube plus 3q square minus 400q minus 500. Now 4000q and minus 400q is first is minus 33q square. 33q square q cube first highest point q cube is minus 2q cube, q square is minus 33 plus 3q square, that is minus 30 q square, 400 4000 q 4000 q minus plus, that is plus 3600 q because 4000 minus 400 q. Then next is minus 5000. This is a function for profit. That is, now here profit with respect to q, d pi by dq. We are finding differentiation of this function, that is profit with respect to q. Then which gives minus 2 into 3 is 6 q square minus 2 into 30 is minus 60q, then plus 3600 into q is 3600, then 5000 value becomes 0 now here because differentiation of constant. Now which is equating 0 we get, look at here, take minus 6 the factor common, q square minus 10q plus 360 equals 0. By solving this, by solving quadratic, we have q equal to minus 30 and q equal to 20. equal to 20. Now take the second derivative for this function, that is d squared pi over dq square equal then minus 12q minus 60. So substitute q equal to minus 30 is what then, which gives second derivative, that is pi to this minus 12. So minus 12q minus 12 q is minus 30, which gives positive sign. So these are, here this is a critical point. This is critical points. Now then pi 2 days at q equal to 20, then minus 12 into 20 is lesser than 0 because negative number. So this first one is concave relative maximum. This is concave relative maximum. This one is convex relative minimum. Relative minimum. We have to take profit maximum profit. Maximum profit, that means profit function, use the point minus 30. Minus profit is maximized at q equal to 20. Why? Because we are using q equal to 20. The second derivative is minimum. Therefore, maximum profit at q equal to 20. Therefore, profit function is profit function, you have to substitute minus 2 into 20 cube minus 30 into 20 square plus 3600 to 20 minus 5000. Finally, we get 39,000 as a maximum profit. Next is we talk about relationship among total, marginal and average concepts. The relationship between total, marginal and average concepts can vary depending on the concept being used. Cost. Average total cost is calculated by dividing total cost by the quantity of output produced. Marginal cost, MC, is the increase in total cost when output increases by 1 unit. MC is the next one. Marginal product can help a firm decide whether to expand or contract production. The marginal production decides whether we have to increase or decrease the production. Then revenue. Total revenue is calculated by multiplying an amount of output sold by the price. The average revenue is calculated by dividing total revenue by the total amount of output. Marginal revenue is equal to the difference in total revenues divided by the difference in total quantity. In a preferably competitive market structure, marginal revenue equals the average revenue. In an imperfectly competitive market, marginal revenue will always be equal or smaller than the average revenue. So far, we discussed about optimizing economic functions as well marginal concepts of the economics. We have done. Please subscribe our YouTube channel.